Alrighty, folks. In the last section, we were talking about hypothesis testing, and we were talking about null hypotheses versus the alternative hypotheses that are possible. In this section, what we're going to be looking at is something called the student's t-test, which is actually just a random name given by a man named William Seeley Gossett. Kind of an interesting story on how it came about. But it basically tests the mean of a population in what we expect the mean to be for that population versus the mean of a sample, and whether that mean of that sample either goes along with what we think the mean of the population should be versus whether that mean of the sample says that our population mean is inaccurate. And so today we're going to take a look at the mathematics behind how we can mathematically show whether that population mean is accurate or if we need to adjust it. Okay? And we do that using the student t-test. Now, in this case, we're going to use something called a test statistic, or what we call a t-statistic, to summarize our information in the sample. Now, this t-statistic, that is what's going to help determine whether to accept the null hypothesis or reject the null hypothesis and accept the alternative hypothesis. Okay? Now, the math that computes this t-value is right here. It's this formula. Now, the nice thing that you need to know is that for this course, you will never have to figure out the t-statistic on your own. All right? You can always use your calculator. In examinations, you will not be required to calculate the test statistic by hand. You can just use your graphing calculator to do that. Okay? So let's go ahead and take a look at how we can apply the t-statistic to compare a population mean with a sample mean and see if that sample mean supports our population mean or if it rejects the population mean and suggests that we should go with a new mean. Okay? Okay, let's take a look at an example of how we can use a t-test to make a decision on whether our null hypothesis should be accepted or our alternative hypothesis should be accepted. Take a look at this example out of your book. It says the manager of a restaurant chain goes to a seafood wholesaler and inspects a large catch over 50,000 prawns. It is known that the population is normally distributed, which we need for normal curves. Now, the person buying the prawn will only buy the catch if the mean weight is more than 55 grams per prawn. So it's unreasonable that the person who is buying these prawns, that he weighs all 50,000 prawns. So what does he do? He takes a sample of the prawns. So he takes a random sample of 60 prawns, and then he finds the mean weight of those prawns and the standard deviation of those weights, right? Now, let's take a look at what's happening here with a t-test. Now, from the previous chapter when we were talking about normal distribution, normally we would put the mean weight here, right? Let's say it's 55. And then I know we would add standard deviations to each side, right? And subtract standard deviations from each side. Oops. And so on, right? Well, one of the things the t-value does is, instead of using this raw normal curve, the t-distribution, instead of using this as your mean, the t-value always changes the mean so that it's a 0. And instead of counting the actual standard deviations, we assume that each standard deviation is 1 unit away from the mean, 2 units away from the mean, 3 units away from the mean, and so on. -1, -2, -3, and so on. Okay? So, now, the next thing we want to look at is, well, when should we accept the null hypothesis and when should we accept the alternative hypothesis? Well, here's the general rule of thumb. All right, once we calculate our t-value, and again, you won't have to do this by hand, your calculator will do this. Here's our decision. If we get a t-value that is between, if we get a value when we're doing this, that's between negative t and positive t towards the middle, then this region right here is called our confidence level. And our confidence, if I knew how to spell confidence, this confidence level says if your null hypothesis is within the area between negative t and positive t, then we accept our null hypothesis. Okay, and therefore we would accept that the mean that we assume to be true is actually going to be true. However, if we get a value that is greater than t or less than negative t, if the value you get right here is outside of these t values, then we would reject the null hypothesis and accept the alternative hypothesis. Okay? Now, how will we do this? Well, as you recall from normal curves, we typically will describe these shaded regions not with numbers, but with percentages, right? So we're going to calculate what percentage that we fall into, either greater than t or percentage less than t, right? Whereas here, for accepting the null hypothesis, it would be a percentage that would be found inside of here. Okay? Now, the next thing. How do we figure out what percentage is acceptable and what percentage is not acceptable? Well, to do this, we have to create what's called our significance level. Now, our significance level is going to be based purely off of our confidence level, right? So suppose that we said that we are 95% sure that the mean that we find is within positive and negative t. The 95% sure is going to be called your confidence level. Well, by definition, the significance level would just be 1 minus whatever your confidence level is. Right? So in the example above, if I said I have a 95% confidence level, then my significance level would be 1 minus 0.95, which would be 5% or 0.05. Now, how do I come up with this confidence level and or the significance level? And that's something that's not really mathematical. That's going to be up to you as the person conducting the experiment, whether it be the person who's buying the prawns, or if you're doing some kind of research for a company, you have to choose the significance level that you want. Okay? Now, typically the standard the standard significance level is 5%, but you can go 1%, you can go 10%, but you will have to come up with a significance level that you want to test against, right? Now, again, let's suppose that our significance level is 5%, right? Well, if I want a significance level of 5%, well, right here would be 2.5% on this side and 2.5% on this side if I'm doing a two-tailed test, right? If I was doing a one-tailed test, then it would be like this, right? Where I'd only come in here. This shading right here would be all 5%, and the confidence level would be everything below that, okay? But you're going to have to come up with the significance level that you're going to have to compare this percent right here against, okay? Now, this percent is typically called the probability value, right? Or the percent value that we're going to compare against, okay? Now, let's actually perform a t-test on whether we should buy these prawns or not using this handy-dandy summary. This summary is what you're always going to do to perform a t-test. Now, this part is going to be up to you on what you're interested in, right? The alternative hypothesis, right? So, in this case, again, I'm buying prawns. There's 50,000 of them to buy, right? We're told that we need the mean weight of the prawns to be more than 55 grams. So the first thing we do is we create our null hypothesis. And our null hypothesis is that the mean is going to be 55, right? So our mean is going to be 55 grams, right? The alternative hypothesis is that the mean from our sample, x bar, which we'll also call in this case mu, is greater than the population mean, or greater than 55, okay? Now, the first thing we need to do is say, okay, what's our significance level that we want to test this at? And again, on a test, I'll tell you the significance level. In your IA, you're going to have to choose one. But typically the standard level that we choose, that we want to compare it against, we want to say that our significance level, we're going to test this significance level at 5%. Or 0.05, okay? Now, once we do this, I'm now ready to calculate the t-value. Now again, you don't have to do this by hand. You can do this by calculator. So let's pull up our graphing calculator to do this. And this is how we're going to calculate the t-value. Okay, this is called the t-test. So the first thing we hit is stat. And because it's a test, I'm going to go over to test, and I'm going to choose 2. Okay, now that first option that you see there is sometimes you'll have to perform a t-test by entering in data into the calculator, right? Well, in this case, we did not enter data. We were given the statistics. So when we do this test, in this case, I'm going to choose statistics as my mode for my t-test. Now, the mean that we're looking for was 55. The mean of our sample was 56.2. So I type in 56.2 in here. And the standard deviation they gave us was 4.2. So I type in 4.2 there, right? Now, N stands for how many prawns were in the sample. We sampled 60 prawns. And again, for our test, our alternative hypothesis, not that they're not equal, not that it's less than, but didn't we want our mean to be greater than the 55? So I choose greater than the population mean, right? From there, I just come down and hit calculate. And this information right here is going to tell me everything that I need to know to complete this problem.